Okay, we're going to talk about volume of a revolution. Before you watch my video, I think it's very important to watch Professor Dave Explains on his YouTube and Calculating the Volume of a Solid Revolution by Integration. The link is right here on your handout, or you could just go into YouTube, type in Professor Dave Explains, and then type in volume revolution, and then you'll find it. He explains it very, very well, but hold off on taking notes because I want you to I want you to see what he does, but I want you to see the example that's on Revision Village when you're starting to practice this. But the critical thing is when you're taking, if you find the area under the curve, um, I'm just going to let you listen. He explains it so well. I don't want to mess you up here. So, so this first example that we're going to do here is using Revision Village. So, um, in order to find the volume of a revolution, we have to do the integral from the beginning to the end, and we're going to multiply it by pi, and we're going to square our height function, because the area pi r squared gives us um, the area of this disk, and we have an infinite number of disks between A and B. And when we find the area of those and then multiply it by the area of this, that's going to give us the area, the volume of a revolution. So anyways, here we have this function y equals x squared, and it goes from 1 to 2, and so my integral goes from 1 to 2, and we've got our pi here, and our function is y equals x squared. So we're going to have that function and squared. Okay, so to type this into the calculator, I guess I watched the Revision Village. He explains it so well. Um, but I want you to uh, watch his video. So I'm going to clear this here. Okay, so how do I get this uh, value from the calculator? So I'm going to hit y equals, and then I'm going to, in my first equation, I'm going to type in pi x to the power of 4. Okay, then I do second trace. I do go over to 7 where it says gives me the integral, and I'm going to go the lower bound. I'm going to type in 1, enter. The upper bound I'm going to type in 2, enter, and now it gives me that value, and so the volume is going to be 19.5. So don't worry about what the picture area looks like. This is going to give us the volume using this formula here. Like I said, Dave explains it really well. His images are amazing. Revision Village explains this specific problem very well. Okay. Now, we can also revolve it around the y-axis as well. And if we revolve it around the y-axis, the lower bound here is along the the lowest part, and then the upper bound here is this higher part along the y-axis. And so, and our function here is going to be the inverse. So basically, what we're going to do is for the, we solve for x instead of we solve for y instead of for x. So if I've got in this equation here is y equals x squared. So if I have y equals x squared, I could square root both sides, and then I would have x equals the square root of y. So this needs to be dy. So we're going to put dy here, and this function is going to be the square root of y. So rather than putting this in terms of x, we're going to put the square root of y. And then, of course, that's the function squared. So, and then square root of y squared is just simply y. Okay, and then so same process. Y equals pi x second trace. Go to 7. Enter. My lower bound is 1. My upper bound is 4. And our volume is 23.56. 23.6. So, I think the revision village, you need to watch that. So the rest of it is simply typing it and putting it into the calculator. Here's the function they give you, x over 2 plus 4. You're going to take this function, square it, and multiply it by pi, and take the integral of that to dx. Okay? So, same thing. You're just going to take that function, the lower bound to the upper bound, put it in the calculator. Now, this is the volume of a revolution around the y-axis. So, we got to use the inverse function. So we switch the x and the y, and then we type it like this. So when we're finding an inverse, we make the y equal to x and the x equal to y, and then we solve for y. And this is the function that we put in here. Although on paper you're going to write y and dy, but on the calculator you're just going to leave it as an x. So let's do this for example. So pi, well, this is the square root of something squared, so it's just 2 divided by, instead of typing it, you can't really type in the y, you have to use an x here. Okay, and then we're going to do the integral. Enter. From 1 to 5. And the volume is this. So in the calculator, I can't type in y. I have to type in x. So that's why we had to find the inverse. And so on the calculator, you're going to be typing in x like I did, and then do the integral. But on your paper, you should write y, because this is really revolving around y, not around x. Okay. Alright, I'm going to leave this here for you to see. Okay. Okay, you might want to hit pause. Okay. Alrighty. Hit pause. Last page. And these you find using your calculator. Okay, I hope that's helpful.